Hello everyone. In the last session, we learned the concept of error, discussed the causes and regularity, and the effective actions to reduce the error in order to improve the accuracy of the analysis results. In the quantitative analysis, to obtain accurate and reliable analysis results, it is required not only to accurately determine the data, but also to correctly record and calculate the results. Since the analysis results indicate the content of the target component in the sample and reflect the accuracy of the measurement, for the record of the experiment data and the calculation of the results, the number of digits is not arbitrarily determined, but is based on the accuracy of instrument and analytical method. Next, let's learn the significant figures and the operations. The significant figures are the actual digits obtained from the measurement. The number of significant figures reflect the accuracy of the measurement. For example, the minimum scale of burette is 0.1 milliliter, and the reading of the used standard solution in titration is 21.10 milliliter. It is clear that the first three digits are accurate data read directly from the burette scale, and the fourth digit is approximate number, which is called an uncertain or suspicious number. So this 21.10 is a 4-digit significant figure. In conclusion, the significant figure is the actual measured number in the analysis work, composed of all the digits known with certainty plus the last uncertain number, which together determine the number of the significant figures. For uncertain numbers, unless otherwise noted, it is usually taken that it may have an absolute error of plus minus 1 units. For example, if the sample mass weight using an analytical balance is 0.5000 gram, it has 4 significant figures, and the relative error of the sample weight is 0.04%. If the sample mass weight used an table balance is 0.5 gram, the data has only one significant figure, and the relative error of the sample weight is plus minus 40%. The calculation shows that in the allowed range of measurement method and instrument accuracy, the more number of significant figures in the data means the smaller relative error and the higher accuracy of the measurement. Conventions of the significant figure. The double meaning of number 0. 0 is a significant figure when used for ordinary numbers, while it is not when just to locate the decimal point. For example, the reading number of the analysis balance is 0.2500 gram, of which the first 0 only plays a location function, and the last two 0 is the number measured, so the number of significant figures is 4. Note: when it's necessary to add 0 at the end of number for positioning, it is better to use exponential expression, otherwise it's likely to cause misunderstanding. For example, if this mass is written in milligram, it should be expressed as 2.500 times 10 to the power of 2 milligram, representing 4 significant figures. If expressed as 250 milligram, its significant figures can only be considered as 3. In analytical chemistry, the commonly used multiple Fraction and non-myriad numbers such as pi, e are considered as numbers with unlimited significant figures, and the numbers are used as necessary during calculation. For logarithms such as ph, pm, and log k, the number of significant figures depends only on the number of digits after a decimal point. That is, the integral portion before the decimal point only represents the power of exponent. For example, pH 10.06 has two significant figures instead of 4. That is, the hydrogen ion concentration is 8.7 times 10 to the power of minus 11 mole per liter. In the data processing, containers or instruments with different accuracy may be involved, and the number of significant figures of data may be different. Therefore, in specific calculations, it is necessary to reasonably determine the number of significant figures according to uniform rules, which is called numerical rounding. At present, the rule of Bunker's rounding is adopted in the numerical rounding. The rule stipulates that when ending in a digit less than 5, the number can be rounded down and can be rounded up when ending in a digit larger than 5. If the ending digit is 5 and the following number is 0, the digit before 5 is taken as reference. That is, if this digit is odd, the number will be rounded down, while the number will be rounded up when it's even. If the digit following 5 is not 0, then the number can be rounded up, no matter whether the number before 5 is odd or even. For example, round the following numbers to have 4 significant figures. The answers are 0.3247, 0.3248, 0.3248, 0.3248, and 0.3249, respectively. It is noted that the original value can be rounded only once. No rounding stepwise, or there will be a rounding error. During the calculation, operational rule of significant figures should be followed. When several numbers are added, the number of significant figures for the calculated results depends on the one with the least number of digits after the decimal point. That is, the largest absolute error. For example, in the calculation of 0.0121 plus 1.05782 plus 25.64, the absolute error of the said number is maximum, which determines absolute error of the sum is plus minus 0.01. So the final result is 26.71. In the calculation of multiplication or division, the number of significant figures for the calculated results depends on the one with the largest relative error. That is, the one with the least number of significant figures. For example, in calculation of 25.66 times 0.0121, the second data has 3 significant figures, and its relative error is largest. Therefore, the calculation result should be taken according to this data, and retain 3 significant figures, that is 0.310. It is worth noting that for the calculation of errors and deviations, it is generally necessary to retain only one significant figure, and the excessive number of digits is meaningless. All errors should be rounded up. Well, this is a significant figure and the rules of operation we have learned today. It requires us not only take measures to reduce errors, but also to record and calculate scientifically, thus improve the accuracy of quantitative analysis. That's all for today. See you next time.